Every time you open your phone, something invisible is working behind the scenes. It decides what posts you see first on Instagram. It picks which song Spotify plays next. It even finishes your sentences when you're typing a text message. And all of it is powered by one thing: machine learning. You've probably heard this term thrown around a lot lately, but most people have no idea what it actually means. They just know it sounds smart and has something to do with AI. So let me break it down for you from scratch. No complicated math, no jargon, just a clear, simple explanation. By the end of this video, you'll understand machine learning better than 99% of people. Let's start with the basics. Traditional computer programs work like a recipe. A human programmer writes out every single instruction step by step. If this happens, do that. If that happens, do this. It's very rigid and very specific. For example, a programmer might write a spam filter like this. If the email contains the word lottery, mark it as spam. If the email contains the phrase "you've won," mark it as spam. If the email comes from an unknown sender and has an attachment, mark it as spam. That works okay for a while, but spammers are smart. They start misspelling words on purpose. They change their tactics constantly, and suddenly, the programmer has to keep updating the rules manually. Every new trick the spammers use means another line of code. It's an endless game of whack-a-mole. This is the problem with traditional programming. It only works when you can predict every possible scenario in advance. And in the real world, you almost never can. So what if instead of writing all the rules yourself, you let the computer figure out the rules on its own? That's machine learning. Instead of telling the computer what to do step by step, you give it a massive pile of examples and say, figure it out. Here are 10,000 emails that are spam. Here are 10,000 emails that are not spam. Now you tell ME what makes them different. And the machine goes through every single one of those emails. It looks at the words, the structure, the sender, the time it was sent, the links inside, and it starts finding patterns that even a human might miss. Maybe spam emails tend to use exclamation marks more often. Maybe they tend to be sent at certain hours. Maybe they use specific combinations of words that a human would never think to look for. The machine picks up on all of this automatically, and it builds its own set of rules based on the patterns it found. That's the learning part. The machine is literally learning from the data. And here's what makes it powerful. The more data you give it, the better those rules become. Feed it 100 examples, and it's okay. Feed it 1,000,000 examples, and it's scary good. Feed it 1,000,000,000 examples, and it starts outperforming humans. That's why machine learning took off when it did. We didn't just suddenly get smarter at writing algorithms. We got access to insane amounts of data. The internet, social media, smartphones, sensors, everywhere. All of that data became the fuel that machine learning needed to actually work. Now let me walk you through the 3 main types of machine learning, because not all machine learning works the same way. The first type is called supervised learning. This is the most common one and the easiest to understand. Think of it like a teacher grading homework. You give the machine a bunch of examples where you already know the correct answer. Here's a photo of a cat. The label says cat. Here's a photo of a dog. The label says dog. Here's a photo of a cat again, labeled cat. The machine studies thousands of these labeled examples. And eventually it learns to look at a brand new photo it has never seen before and correctly say that's a cat or that's a dog. The supervised part means a human supervised the training by providing the correct answers. This is how email spam filters work. This is how Netflix predicts what you want to watch. This is how banks detect fraudulent transactions on your credit card. All supervised learning. The second type is called unsupervised learning. This one is a little different. Here you give the machine a bunch of data, but with NO labels. No correct answers. You just say, here's a pile of information, find me something interesting. And the machine starts grouping things together based on similarities it discovers. It's like dumping 1,000 marbles on a table. Some are big, some are small, some are red, some are blue. Without anyone telling it what to look for, the machine would start sorting them. Oh, these all seem similar, let me put them together. These look different, I'll make a separate group. This is called clustering, and businesses use it all the time. An online store might use unsupervised learning to group customers into segments. It might discover that one group tends to buy on weekends and loves discounts. Another group only buys premium products and never waits for sales. The store had no idea these groups existed. The machine found them on its own. That's incredibly valuable for marketing and business strategy. The third type is called reinforcement learning, and this one is probably the most fascinating. Imagine training a dog. The dog does something good, you give it a treat. The dog does something bad, no treat. Over time, the dog learns which actions lead to rewards and which don't. Reinforcement learning works exactly the same way. The machine takes an action in some environment. It gets either a reward or a penalty based on the outcome. And over millions of attempts, it figures out the best strategy to maximize its rewards. This is how AI learned to beat the world champion at the board game Go, a game so complex that there are more possible moves than atoms in the universe. The AI played millions of games against itself, losing at first, then getting better, then getting incredible, until no human on Earth could beat it. Reinforcement learning is also how self-driving cars are being trained. The AI drives in a simulated environment millions of times. It crashes, it learns, it adjusts, it runs a red light, gets a penalty, learns not to do that, it successfully navigates a tricky intersection, gets a reward. Over time, it becomes a better driver than most humans. That's the power of reinforcement learning. Now let's talk about something you've definitely heard of. Neural networks. This is the technology that made modern machine learning so incredibly powerful. Neural networks are inspired by the human brain. Your brain has about 86 billion neurons. These neurons are connected to each other and they pass signals back and forth. When you learn something new, certain connections get stronger. That's how you form memories and recognize patterns. A neural network is a digital version of this. It's made up of layers of artificial neurons. Data enters through the first layer called the input layer. It gets processed through one or more middle layers called hidden layers. And it comes out the other side through the output layer as a decision or prediction. Each connection between neurons has a weight. During training, these weights get adjusted based on whether the network got the answer right or wrong. If it got it wrong, the weights shift slightly to improve next time. This happens millions of times during training. And gradually, the network becomes incredibly accurate. Now, when you stack a lot of these hidden layers together, something amazing happens. The network can learn extremely complex patterns. We're talking about recognizing faces in photos, understanding human speech, translating between languages in real time, even generating brand new images and text from scratch. This is called deep learning. Deep just refers to the depth of the neural network, meaning it has many layers. And deep learning is the technology behind every major AI breakthrough you've seen recently. ChatGPT uses deep learning. Midjourney uses deep learning. Self-driving cars use deep learning. Voice assistants use deep learning. It's the backbone of the modern AI revolution. Now let me show you how machine learning actually works in your daily life. Because it's everywhere, and most people don't even notice when you type a message on your phone and it suggests the next word. That's a machine learning model that was trained on billions of sentences. It learned the patterns of how humans write and predicts what you're most likely to say next. When YouTube recommends a video on your homepage, that's a machine learning model analyzing your watch history. What you clicked, how long you watched, what you skipped. It compares your behavior to millions of other users and finds patterns. People who watched what you watched also enjoyed this video, so it suggests it to you when you apply for a loan at a bank. There's a good chance a machine learning model is evaluating your application. It was trained on thousands of past applications, people who were approved, people who defaulted, and it learned the patterns that predict whether someone is likely to pay back the loan. When you ask Siri or Alexa a question, machine learning converts your voice into text. Another model interprets what you meant. Another model generates a response. And another model converts that text back into speech. Multiple machine learning models working together in a matter of seconds. It's honestly mind-blowing when you think about how much is happening behind the scenes. Now here's something important to understand. Machine learning isn't perfect. It's only as good as the data it's trained on. If you train a model on biased data, you get a biased model. For example, if a hiring algorithm was trained mostly on data from male employees, it might learn to favor male candidates even though gender has nothing to do with job performance. The machine isn't being sexist on purpose. It's just reflecting the patterns in the data it was given. This is why data quality matters so much. Garbage in, garbage out. And it's why there's a huge conversation happening right now about AI ethics and fairness. Making sure these models are trained responsibly is one of the biggest challenges in tech right now. Another limitation is that machine learning models can be wrong and make predictions based on probability, not certainty. A model might be 98% accurate, but that 2% error rate can matter a lot depending on the application. In medical diagnosis, a 2% error rate could mean misdiagnosing thousands of patients. In self-driving cars, a small error could mean an accident. So while machine learning is incredibly powerful, it's not magic. It's a tool that needs to be used carefully and responsibly. Now here's why machine learning matters to you, even if you're not a programmer. This technology is reshaping every single industry. Healthcare. Machine learning is detecting cancer in medical scans earlier than human doctors. Finance. It's predicting market movements and detecting fraud in milliseconds. Education, it's creating personalized learning paths for every student. Entertainment, it's generating music, writing scripts, and creating art. Retail, it's predicting what customers want before they even know they want it. And this is just the beginning. Machine learning is advancing faster than almost any technology in human history. The models are getting bigger, smarter, and more capable every single year. 5 years ago, no one thought AI could write essays or create photorealistic images. Now it does both better than most humans. 5 years from now, machine learning will be doing things we can't even imagine today. The people who understand this technology will have an enormous advantage, not because they need to build the models themselves, but because they'll understand how to use the tools built on top of them. And that's what I'm here to help with. Breaking down these complex topics so you actually understand what's happening, and more importantly, how to use it to your advantage. If this video helped things click for you, smash that subscribe button. I'm releasing new videos every week, breaking down AI, tech, and the tools that are changing the world. You don't want to miss what's coming next. See you in the next one.